So in lesson number 3, we're going to talk about 802.1x, the Extensible Authentication Protocol Framework. Really important concept, because when it comes to modern encryption and modern authentication techniques, these are definitely tools that we use every day, not only for wireless clients, but for wired clients as well. If you guys decide to go on to, say, CCNP, wireless, or even get into the security realm, you're going to have to know quite a bit about these particular this particular framework. Okay, separating authentication from encryption, a very key element to improving security. We don't want to have those two functions tied together. If the authentication method is strong, it's probably too heavy to be kind of reutilized in the process that would help encrypt each packet as well. What I mean to say by that is that we typically use different processes for authentication, which generally will require a slower process, a more robust process than if I want to do my bulk encryption. Okay, bulk encryption is the process where we're encrypting our data going back and forth. If the algorithm that's used for the encryption process is too fast, conversely, that's probably going to be too weak to resist maybe brute force attacks or other types of attacks that would exist against authentication. So we use fast algorithms for packet encryption, but not to send and receive passwords for that particular session. This is why we always talk about how encryption and authentication should be kept separate from each other. And that's really what we focus on in this particular lesson. We really only have one thing that we want to learn here, right? And that's what is 802.1x, what are the different components, and how does that apply to a wireless network? Now, I will preface this whole discussion by saying that we could spend 3 or 4 days talking about 802.1x and extensible authentication, and especially in the wireless space, because there are so many different extensible authentication options. And I do think that as we progress through some of the lessons here and we move further into this security section, we'll get some more detail on those different protocols. But it is a very wide reaching discussion. In this particular network that you see here, authentication is the first point that has to be improved, right? Common authentication key for all the users. We already talked about how many risks that involves. If one key is compromised, then everybody's exposed to the breach. And that risk then leads to the need for, changing whatever authentication method you decide to use. Usually that means the use of individual authentication keys. But then that in and of itself leads to other issues, like scaling issues, and having to manage all those individual keys and identify how those individual keys are utilized. So what do we do? All right. If a user plugs in a new device into a switch, how do I authenticate that user? Right? We're talking about wireless, but again, this is a protocol, 802.1x, that supersedes wireless and fits just about anywhere. Do I authenticate the user? Do I simply statically put that device into a VLAN and allow them access based on static access rules or whatnot? Well, with 802.1x, we don't have to do that. Okay. In 802.1x, there are 3 primary roles, and you can see them listed on the diagram here. The supplicant, which is the device that's wanting to gain access to the network. The authenticator, which is what we call, kind of funny, lack of a better term, a NAD, network access device. That's the point essentially where we're trying to gain access to the network. It could be a switch, or in this case, an AP. The authenticator is not actually doing the authentication. It's proxying the messages back and forth, and it's relaying the information. But the authentication server is actually the device that keeps a list of all the conditions that we use to grant access or refuse access to the network. So in the 802.1x process, the supplicant connects to the authenticator. At that point, the port on the switch, or in this case, the wireless access point, has not been authorized, right? So no frames are passed from the port. No frames are allowed to be sent or received. The only thing that's allowed are what we call these EAP messages, Extensible Authentication Protocol over the LAN. All right, now the idea is that it's a closed door policy, so if you don't authenticate correctly, you're not going to be able to gain access to the network. So that's why you see a designation there that only 802.1x traffic is allowed. If the wireless client is trying to generate other types of traffic, that's not going to be allowed to pass. All right. Now, if the supplicant that is attached to the switch doesn't send an ID, the port stays unauthorized. And then the port doesn't pass traffic. The authenticator, again, typically via switch, but in this case, the access point, receives an ID from the PC, which is the supplicant, and then it passes that ID information on to the authentication server. In that authentication server, there's a database, a list of users. They can verify that identification information. That radius server then responds to the AP with either a success or a failure message. And there's actually more steps that take place here, right? Because there's various messages that are being passed back and forth. I'm just describing high level what's occurring here. Okay? If the response is a success, then we can pass traffic. If the response is a failure, the port remains unauthorized, and so on. All right? Now, when I'm dealing with this over a wired network, it's a pretty straightforward process. You plug in, the link status of the port indicates that somebody's connected to the port. There's a supplicant, usually a thin client that's installed, or it's built into the operating system on the supplicant, or you can use AnyConnect, the Cisco AnyConnect client, to act as a supplicant. We'll start to send in those messages. What happens if the authenticator is a wireless access point? In this particular case, connecting to the authenticator represents 4 distinct steps of an open authentication process. We still start with open authentication. The supplicant, the client, sends an authentication request, receives an authentication response with a success status, and for that reason, the wireless network that uses 802.1x is kind of seen by wireless scanners as having open authentication, even though it's open to associate to the SSID, but it's not necessarily guaranteed that you're going to be able to pass traffic. You're still able to pass .1x traffic, but you can't pass regular data traffic. So what happens in this particular process is the supplicant sends an association request, receives an association response with an association identifier, what we call an AID. Even after the association is granted, the port is still blocked, right? Because the client hasn't really technically authenticated. We haven't sent the access request over to the radius server. So the wireless client can't access the network further. It now has to go through the authentication mechanism. So we start the process, or the authenticator can take the initiative by asking for the credentials directly. Usually the client will initiate the process. So the authenticator receives authentication credentials from the supplicant. We encapsulate that into 802.1x traffic. That then gets sent back to the authentication server. All the other network traffic is still blocked because we haven't successfully completed the authentication process. After we receive a radius traffic back from the radius server indicating that the client has been authenticated, now we can continue, or we can essentially process data. Just by simply implementing this process, we're not only authenticating the client, but aren't we technically authenticating the access point as well? Because a rogue AP certainly wouldn't have credentials and access to communicate to the radius server. It would you would have had to have compromised the radius server, install a profile for that radius client, and set up the authentication for that radius client. So this is a way for us to essentially ensure that we're connecting to an access point that's legitimate. Okay. Now in the 802.1x model, we did talk about 3 roles are defined. That doesn't necessarily mean 3 physical devices. Radius can actually be configured directly on the wireless LAN controller, or it can even be configured on a standalone AP if you're not running autonomous wireless networks. All right. Now, an important aspect of 802.1x is that it authenticates each supplicant individually. Right? You know, whether it's open, so there's no initial key that needs to be identified. And then we have individual user accounts to identify the individual users. So that's going to improve the overall authentication security, the level of security that we have with authentication. Wireless networks usually take advantage of this individual authentication to add individual encryption as well. So while we're authenticating through the 802.1x process, the client and the Radius server derive an individual key that's unique for that device and that particular session, and that's what we use for the bulk encryption process as well. The Radius server actually sends an access success message and what we call a session key to the client through the access point. And then the AP then forwards that over to the client. The client and the AP then begin using that session key, and then the AP also sends the client a broadcast and multicast key, kind of a generic key. So there's always two keys that are used. The broadcast and multicast key is common to all the clients, but then each individual user has their own individual session key. Every single time the client associates to an access point, it has to re-authenticate to the Radius server, obtain a new key, go through the whole process all over again. So you can already see the huge benefit here. Certainly much better than WEP, even with TKIP, even better than WPA personal mode or WPA2 personal mode, because in both of those modes we just have a pre-shared key. So using 802.1x authentication means that each wireless client can then be granted a new dynamic key each time they access the network and so on. This process, right? This process of having these dynamic keys, that's called the session key. Each user has a unique key for that connection time only. All right, so let's take a look at the extensible authentication protocol in a little bit more detail. All right, what you're seeing here is just the packet format, it's, let me see if I may have, yeah, I skipped a slide, sorry about that. I don't want to talk about the packet format until I talk about the process first. I think that's important. So let's talk about the process and then we'll talk about the packet format. So 802.1x provides obviously authentication, and we talked about the 3 roles, etc. We talked about the fact that the port is blocked until the authentication process is completed. All right. Now, the 802.1x architecture does not contain protocol specifics for wireless clients, meaning that if I want to send my credentials to the authentication server, I can use different methods, right? We don't specify how the authentication should occur. You might use CHAP or PAP, or you might use other methods, right? Even in the extensible authentication realm, there's lightweight extensible authentication protocol, there's the PEEP, there's EAP Fast, there's EAP TLS, many different types of authentication. In order for us to be able to identify a standard process, the Internet Engineering Task Force, or IETF, came up with the extensible authentication protocol. It's called a protocol, and it does have protocol specifications, but it's also kind of like a framework. It's a general protocol, meaning that it doesn't define specifics, but it supports authentication and multiple authentication methods like token-based authentication, Kerberos, one-time password certificates, PKI, smart cards, etc. The assumption behind EAP is that the authentication process always has the same choreography, right? Meaning that the process is the same every single time, regardless of whatever authentication method that you're utilizing. We request access, we're queried for our identity, the client then proves its identity through one of those methods, a token card, a one-time password, a certificate, etc. It receives an answer, success or failure, from the authentication server. We define the typical header to match each of those particular steps. So the type of packet, whether it's a request, a denial packet, the direction from the client to the server or back and forth, those are defined in the header as well. All right. EAP does not imply 802.1x, by the way. EAP is just another protocol that defines typical headers and the process, the choreography, like I said, that the authentication process includes. All right. Proving identity, etc., etc. It can get really, really confusing. It took me a while to really kind of understand all the facets of this particular protocol because there are so many varying kinds. And we will talk about them like PEEP and EAP Fast and EAP TLS. I don't know how much in the CCNA level we get into it. Certainly in the CCNP wireless we get into it in a lot of detail. EAP does not specify the type of authentication, like I said. It simply defines the steps. So it carries an authentication type field, right? That's a new authentication type can be used if it's ratified. So we can define the authentication method within that field. And then it defines 4 separate message types. You have an EAP request, you have an EAP response, you have an EAP success, EAP failure. Pretty basic, right? Logically, that makes sense. Those would be the 4 things that we would see. Any side can have the initiative, right? The AP can take the initiative and say, give me your credentials. Or the client can say, here are my credentials. It doesn't really matter who's starting this process. Some mechanisms authenticate the client. Other mechanisms authenticate the client and the server. Or other mechanisms authenticate the device or the user or many other things. Depending on the level of security that you need in the network, you can implement different mechanisms. And every one of these has unique characteristics. PEEP, EAP Fast, EAP TLS, and so on. All of these protocols, in a wireless network anyway, rely on the 802.1x specification. To carry, to provide the authentication to the port. EAP is what we use to carry the authentication exchange between the client and the server. So what kind of devices can I use to perform these functions? Well, there's quite a few actually. Typically in the past, it could either be integrated into the wireless LAN controller using a local AAA server. You can have some sort of back-end integration to an Active Directory domain. You can have it included directly into the wireless access point, or what we see today quite often is have some sort of globally centralized server, either Cisco Secure ACS, which has kind of been integrated into ICE, or the Cisco Identity Services Engine. All right. We don't get into ICE too much in this class. In fact, I think there's one optional exercise where you might configure one thing in ICE. But when you get into the CCNP wireless, you're going to get into ICE quite a bit. I imagine, Mike, probably teaches you as well, that ICE is a component of your overall security architecture. I'm not sure if that is or not. Just give me a little smiley face if it is. But, that's pretty typical, right, to include that as part of your overall security architecture. I would suggest there is a course that is part of the CCNP security track that is specifically for designed for with ICE, and it is let me think. It's not SIMOS, SISAS, implementing secure access solutions. Cisco Secure Access Solutions. That is essentially an ICE course. So if you are challenged with managing ICE, and it is a CCNP level class, but there is no real CCNA level class that covers ICE. So definitely take a look at that SISAS course if you have to deal with ICE. It's used for everything, right? Wireless, wired, etc. Okay. So that really concludes this chapter. Very basic introduction. Like I said, we're going to do a deep dive into a lot more of this as we move into this tomorrow. I think you'll find it very interesting. So we talked about 802.1x. its basic functionality in the wireless network, how the extensible authentication protocol creates this framework to carry that process back and forth between the supplicant, the authenticator, and the authentication server, how the wireless LAN controller can relay wireless client authentications to an external radius server like ICE, or we can be configured to do the process locally on the controller. We are going to set that up on the controller as part of our discussion going into tomorrow. We're going to start with the client configurations, and then we're going to move into the switch configurations, and then we're going to move into basic, some of the additional configurations. All right, so that wraps up this lesson. In the next lesson, we will be talking about the EAP authentication process, but we're going to get into it in more detail, right? Talking about the public key infrastructure and how that works. Take a look at EAP TLS, PEEP, and EAP Fast in detail, where you get to learn about what the difference is between these different extensible authentication protocol methods look like. Okay, so that'll be a really, really interesting section that we'll get through.